Introduction to Optimization, Questions for Screen Recording Task, Part 1, Gradients and Hessians. Question 3. Derive gradient of trace of matrix power, trace of x in the power of k. We will first show an argument. Let x be a matrix. We will show that the differential of the trace of x is the same as the trace of the differential of x. So we see that the differential of the trace of x is the same as the differential of the sum of the elements in the diagonal of x. So we know that the differential of a sum is the same as the sum of the differential of each element in the sum. And then we get the differential of the sum of the elements in the diagonal equals to the sum from I equals 1 to n of the differential of xii. And that gives us the trace of the differential of x. And now we can show the differential of the trace of x in the power of k. So the differential of trace of x in the power of k equals to the trace of the differential of x in the power of k. That we can see by the previous argument. And now we will open this expression and get the trace of the differential of x multiplied by x k times. We will use the rule of differential of multiplications and get that the trace of the differential of x multiplied by x k times is the same as the trace of differential of x multiplied by x k minus 1 times plus x multiplied by the differential of x multiplied by x k minus 2 times, and so on until the last element of the sum is x multiplied by x k minus 1 times multiplied by the differential of x. Now we know that trace is a linear function, so each element in the sum can be inserted inside a trace. So we get the expression of trace of this element and trace of this element and trace of this element. Now, since trace is a cyclic function, we can move each element of the sum to look of this shape, and then we get that all elements look the same. Now we can sum them. So we have k elements in the sum. Then we know that each element of the sum is x multiplied by x k minus times multiplied by the differential of x. So we get trace of x in the power of k minus 1 multiplied by the differential of x. And as I said earlier, we have k elements like this in the sum. And then we can write that this sum is k multiplied by trace of x in the power of k minus 1 multiplied by dx. Now, since k is a scalar, we can insert it to the trace and get the trace of k multiplied by x k minus in the power of k minus 1 multiplied by dx. Now, this expression is the definition of inner product of two matrices. So we can write it as the inner product of k of x on the power of k minus 1 transpose with the differential of x. Now, k is scalar and x in the k minus 1 is a matrix. But we know that x in the power of k minus 1 transpose is the same as x transpose in the power of k minus 1. And so we got the differential of the trace of x in the power k is the inner product of the scalar k multiplied by the matrix x transpose in the power of k minus 1 with the differential of x. So by the definition of the gradient, you can see that the gradient of the trace x in the power of k is the scalar k multiplied by the matrix x transpose in the power of k minus 1.